welcome to this month's Developer Forum, shifted by a week from its normal spot. So thanks for turning up. And that was all done to accommodate the release of, I guess, R and then the following day Bioconductor. So I should really start this with a big thank you and congratulations to everybody from the core team for managing another release cycle and all the announcements and updates and deadlines and everything that accompanies that. So it seems certainly from a user point of view that that's all gone really well, really smoothly. So thanks very much everybody for that. And then yeah, the kind of idea for today's session that I had was timed to go along with this was that it would be almost like a show and tell session where there's this huge list of things that have changed, some small, some quite large in R over the past year, and then maybe people would be interested in one or more of those kind of new features or a little bug fix that either has affected them or resolved a problem that they had, or maybe they submitted the patch for it or something. So I was kind of hoping that basically people would come along with their favorite new thing that's changed in R over the last year and maybe share it with us and show how it does something new, or maybe it's broken something that they were working with before and it behaves differently now. So I didn't get much response on the Slack channel as to whether people were going to do this. I'm hoping that Martin is still willing to at least talk about the new pipe, which is probably the biggest change in this iteration. So I'm getting a thumbs up from Martin. So if other people have things they want to talk about, that would be awesome. If not, I've got a few things that I've prepared as well, but I will let Martin go first if there's no other people that put their hand up right now. Great, if you want to either talk or share your screen or whatever you need to do, Martin.
I'll try and share my screen. And I'm not sure why I'm so enamored with these pipes, but I am. I haven't really been like a tidyverse user or thought that pipes were really wonderful before, but somehow the scales have fallen from my eyes. So I've just started an R session over here. This is in Emacs. I hope you can see my screen. And,
yeah, it looks good to me.
And this guy here, the percent arrow, greater than percent, is a Magrittr pipe introduced in this Magrittr package and used extensively in sort of tidyverse land. And if you're just in a new R session, it doesn't work because you haven't loaded the Magrittr package. Whereas in R 4.1, there's this new operator, vertical bar greater than sign, that does the same thing, but is available in base R. So that's the feature, I guess. Before you'd have to use it by loading the Magrittr package and probably dplyr, R, and then you'd have this tibble that was empty cars, and then you'd use the pipe in dplyr syntax to perform a series of data transformations, sort of filter and then select, and come up with some subset of your data or whatever it was. And then the same thing works with the base pipe instead of with Magrittr being loaded. So it seems like superficially everything that you could do with dplyr and Magrittr is functioning, and maybe also because it's in base R, it kind of separates the pipe operation or makes it clear that it applies to anything that you'd want that's suitably formatted. So it doesn't have to be a tibble; it could just be a data frame, as it was in this first expression here, or a genomic ranges or a DNA string set. Anything that sort of satisfies the rules of the pipe operator are sort of eligible for piping. I kind of have a bunch of sort of pros and cons or benefits of, or why you might want to use the base pipe as opposed to the Magrittr pipe. So the first one is, of course, that it's always available as opposed to some specialized package, but maybe that's not so important. A second one would be kind of interesting to hear about. For me, it's easier to type these 2 characters than the percent greater than percent. It's actually a shift key, to type that, it's a shift key and then one key and then another, versus a shift key, one key, another key, another key. So it's only really saving me a keystroke. But actually, I understand in other keyboards, and maybe people could chime in here, that actually that's not the case. They're both equally complicated to type. I don't know if people have European keyboards out there, and how many keystrokes does it take to type either pipe? Anyone want to chime in?
So for me, it's shift down, press 1 to get the bar, keep the shift down, and another press to get the closing triangle bracket. So yeah, for me, it's one change as well, because it would have been shift down %, triangle % again, right, with the old version. And at the moment, it's definitely slower because it's not intuitive at all to me.
I see. Yeah, so not so bad, but still quite awkward, I guess. But c'est la vie. Yeah. That's kind of trivial. So this idea that this pipe was popularized by tidyverse but works anywhere. So here's the sort of equivalent operation, but using a base function called subset, which happens to combine the filter and select operations into a single function call. So just illustrating that you don't have to be using the tidyverse to be using a pipe. And I think that's actually really valuable to recognize. Here's one difference. In the Magritter pipe, you can be kind of lazy, and you don't actually have to include the parentheses on the function call. Whereas with base pipe, it says, I don't know what you're talking about. You need to have parentheses, and then it works. So it's like you need to have these parentheses. And at first that seems like, wow, that's really inconvenient. It was super easy to write things without the parentheses. But the motivation, I guess, is because it provides for a level of consistency. And my little example here is kind of like consistency, but it isn't too compelling at some level. But the idea of consistency in general is good. So here's a function that returns a function. So f is a function that returns a function. And if you evaluate f, then you get the result. So like g here is now a function, and you evaluate g and it returns the result. So that in Magritter, there we go. So in Magritter, that works, and this also works. This doesn't work because it's trying to say, well, f is a function that takes 0 arguments that returns a function that takes x arguments, but somehow g and f are the same, right? So shouldn't they both work, or neither of them work, right? So there's like a kind of an inconsistency that's present there. And at least pipes are consistent in the sense that g doesn't work and f with single parentheses doesn't work, whereas g with parentheses and f with parentheses and parentheses. So a function call that creates a function evaluated that way works. So there's a level of consistency there that is a little bit unintuitive, and maybe it doesn't seem like such a big deal. But actually, the consistency means that you're always going to be able to have a set of rules of grammar that will make your life easier in the long term. I don't know. Do people have thoughts on that one?
So I didn't even realize that you could use the Magritter pipe without the brackets, right? Until reading about the changes, I didn't know that was a thing. But maybe that's because I've written too much pre-Magritter code, and it's completely ingrained in me. But yeah, I was quite surprised that was a selling point, because I didn't know it was something you could do with with Magritter itself.
Yeah. I guess it's like laziness. That's one of the virtues of programmers is being lazy, and not having to type an extra set of parentheses was somehow a feature that Magritter actively supported, but that BaseR has decided not to support. Another kind of thing that's a difference between a Magritter pipe and a base R pipe is that Magritter allows you to use the dot as the location where the thing that's coming from the left-hand side belongs. So here's a little, create a plot, miles per gallon as a function of cylinder. And the way that plot works is that the data argument, the data frame that miles per gallon and cylinder are coming from is actually the second argument. And Magritter says, okay, so you can put the second argument or specify the location of that second argument by using a dot. And so you'd write this, and I realize now that you're not going to see it, but off screen, it actually generates a plot, right? So that works. But if you try and do that with the base pipe, it says, I don't know what dot means. There's no special meaning for dot for me. And actually, just from the I'll reveal some internals of our core discussion. I think the prime motivating reason why the dot isn't supported is because the guy who implemented the base R pipe, Luke Tierney, found the dot really hard to discern, just visually. And also the dot could be like you and I could define a variable dot. I think we could anyway. And then it's ambiguous about what the dot refers to. Does it refer to the dot in the global environment that I just defined, or the dot in the pipe? But I think it was actually mostly that it was difficult to discern what the dot referred to, and couldn't come up with a kind of appropriate symbol that was brief and captured the notion of this capturing the argument. And I think there was also some hope that actually there'd be a better solution that, with the anonymous functions. But actually that didn't work out. So the way that you'd do this is you'd re-implement plot with a function that does take as its first argument the data, as opposed to the formula or the x and the y variables that you're going to plot. And then having re-implemented that, you could go ahead and do the operation that you performed. So, like at the moment anyway, the base R pipe is kind of strict. It requires that the first argument is actually the data argument. And then I'll say one more thing about the base R pipe. And I was really hoping for some really spectacular example, but I think this spectacular example only comes up in real life when you have a complicated set of pipes and you get an error somewhere in that pipe, and you ask R, where did that error occur with a traceback, and it gives you the traceback is a series of system calls, and you have to understand that you have to interpret each call in a way that's consistent with the way that the Magritter pipe works. So you kind of have to know what this pipe actually does in detail, and I'll try and just illustrate this very superficially, not very satisfactory at all. So f just is a function, and it ignores its incoming argument, and it prints out the calls that you see by the time you get to f. So the function f sees that it's been called by this pipe, and if it were sort of more complicated, like it took an argument and the argument failed, this pipe would be expanded. Each step would be expanded into a call stack. So it's kind of illustrating that by the time you get to evaluating this expression, you've only sort of partially transformed it into a standard R grammar, whereas the base R pipe says by the time you get to F, what you've actually done, because it's implemented at the level of R's parser, what you've actually done is you've transformed this sequence of pipe operations into, it really is like a nested call. So you've started with Tibble, and you've called filter on it, and you've called select on the result of that, and then you've called F. So it's actually transformed this expression into this expression. And again, the idea is that this is familiar in a sense, so that when you see an error at any of these steps, at least you're on the same footing as you would be using standard R function calls. You're not having to understand and parse the individual steps in the pipeline. I don't think I've really illustrated that very well, but the idea is that the base R pipe is generally much more straightforward to debug than the Magritter pipe.
So I tried to do the same thing. If I end up sharing my screen, I have a similar thing where I couldn't come up with this spectacular example, but I don't want to put you on the spot in case this doesn't work, but could you break that call and then show us what the debugging looks like for the two? So for instance, I guess in select, you could pick a column that doesn't exist or something, and that feels like an error that's definitely going to fail. But I don't actually know what the debugging will look like.
Yeah, that's pretty good. So let's see. And then we say, so if I were to try and, that's pretty good. That's great, Mike. So yeah, so here I've said, in some ways the error is self-explanatory, or I could guess at what the problem was, but it could be subtler. So I've misspelled the column name, and then I see the error and I can't figure out the error message. So my go-to would be to use traceback to kind of, like, all I know, like here I could have gone on and said like head, right? And then I don't actually know, where in this pipe the error occurred. So I'd say, well, like I'd have to decompose it, I guess, into its different components, and then it's like, oh boy, now I know that I started here, and it looks like maybe the problem was in head, but it wasn't actually. It was because head was calling select, and it was inside select that the actual problem was, and then I have to go back all the way up through here to see what the problem was. So what happens with the base R pipe? I'm not sure that it's going to be very much. Let's try and see what happens. Maybe we'll can't subset. So actually the error is the same. And I'm not sure that we get actually, starting here, we see that we get a better sense of what's going on, right? We're calling these nested function calls, and then I guess we actually end up basically at the same call stack that once we get down to select data frame, all of this stuff is sort of within that. So yeah, so I guess we're seeing the almost seeing the same complexity of error stack. So I guess it's not. There's one less layer here, 14 versus 13, but maybe we haven't come up with a. It's really this first step that we're understanding that the problem is in this nested function call as opposed to in something. It looks like the problem here is in head, but it's actually in select, the previous step.
If you follow the, I guess the third line of the message says run r lang last error, which I always ignore as well and do the same as you and run traceback. But is that more less verbose, more informative? I'm not sure what I want it to do, but
Well, actually, I think that what this Erlang last error is trying to do is like you and I right now don't have a really good example, but it's trying to simplify the presentation of the call stack. And actually, to me, it doesn't help. Yeah, but I think it's trying to deal with this the complexity of parsing an error that occurs with the pipe, or at least in part.
You have a question in the chat too from Robert Costello about what about performance? Is there a difference due to the different approach to parsing the pipes?
Yeah, probably, but it's probably minimal. So like, but I mean, this is the base R pipe is implemented as part of the R syntax, so it's like a parser. So really, what happens is before anything is evaluated, let's go back up here and see here. You can kind of think about you're sort of typing along, and then you press the carriage return. And for the base R pipe, when you press the carriage return, the first step is to transform this expression into this expression, right? And then, so like there's this, the parser does the transformation, and then you call R's standard evaluator to evaluate this expression. Whereas with Magrittr, you get this expression, and the way that it works is, and you can kind of see, I've got this, and then R says, okay, so now I'm going to evaluate this. So how do I evaluate this? Well, I look up the symbols and I see that there's this pipe operator, and the pipe operator has, or this pipe symbol, it has percent greater than, it has a percent precedence. So then it evaluates, according to whatever the rules are, the precedence rules, it evaluates, say, this, and then the remaining stuff over here. And then it says, okay, for the right-hand side stuff, what do I have to do? Well, I have to evaluate this, and I see a percent operator, and the remaining stuff over here. I feel like I've got the precedence wrong. But each of these things will be evaluated, run through the parse tree, the evaluation step separately. So actually, the base R pipe is more efficient, maybe much more efficient than the Magrittr pipe. But whether that actually, adds up to meaningful performance consequences for you and I is probably it doesn't. I'll just conclude and then hand it back to Mike, but say when people see pipes, one common sort of concern is that like if you hang out on Stack Overflow and you look at someone's solution with pipes, them often pipe together these long expressions that do some miraculous stuff. But in many ways, the system version of a pipe shows you what's wrong with that. It's like this highly nested call that logically you can't really get your head around. And it's the same kind of, argument about when you write a more traditional set of, write code in a more traditional way. One line creates a result, and then you do another line that creates a result, and then another line. And that stepping through those things can be very valuable, both when you're writing the code and when you're debugging it. And in the same sense, this just as you wouldn't want to write a highly nested function call, you also don't want to write pipes that go on for multiple lines and do an amazing thing because you lose the intermediate results. So you might write something, a pipe that was like this, that was 3 or 4 statements long, but you wouldn't want to write a pipe that was longer than that, and you wouldn't want a pipe that the individual steps were amazingly complicated. Like you wouldn't want to implement your entire RNA-seq analysis as a series of piped calls. Instead, you'd want to just to understand it yourself, and because you want to step through it, you'd write it as a series of much smaller piped expressions that you do capture intermediate results at important points. So kind of like tempting to write pipes that go on forever, but best practice is probably to really use the pipe as a way of grouping small logical operations into a coherent whole.
So thanks a lot, Martin. That was really nice. Does anybody else have any questions about the new pipe and things for Martin? Cool. If not, then yeah, I guess I'll open the floor for anybody else that has something else they want to share. And if not, then I will share my screen and talk about a couple of other things. Okay, I guess that's my cue. So I'm not quite as organized as Martin. I put some examples in a HackMD thing for people to click through. So I've just shared a link to it if you want to look at the code and things. So yeah, there's just a few examples. So hopefully you can see my screen. There's a white web page on the left-hand side, and then there's two R terminals on the right. Can someone let me know that you can see that?
Yes, we can.
Perfect. Great. Thanks, Laurie. Yeah, so the two terminals on the right, because a couple of these are going to compare things from R4.0 to R4.1. So the top one is R4.0 and the bottom is the new 4.1. And hopefully to help you remember that, there's just right in the title is the two versions of R. So you can see I had a little bit about native pipes as well, like Martin's just done. He went into a lot more detail than I was going to do. I just had a question about whether the stack traces really are easier to read. So I'm not sure we definitively said that, but I'd read it in a few different blog posts without any examples. So I'm very glad Martin at least sort of held our hand through going through a few examples, even if it didn't make it totally clear. Because maybe it's just really tricky to debug pipes, no matter who's implemented them. So I guess the one other kind of new syntax that has been introduced in this new version of R is this ways of defining anonymous functions. So essentially functions where we don't give them a name. We saw in Martin's example that he had a piped plot and then assigned it with this kind of format we're used to with the function name, with the name function, the arguments, and then the contents of whatever the function's going to do. And there's actually a new way of defining functions with just this slash operator, which I think the intention for it is to kind of be a slightly more succinct way of defining functions when you don't actually want to keep them around, you don't want to give them names. So I guess we're sort of principally thinking about using them in the apply family of operations and things. But I guess maybe there was already some intention to use these in a really elegant way with the native pipes and things, but it sounds like maybe that hasn't quite come together. There are ways to use them, and I've got a couple of examples here, but I guess just to start with, since this is an entirely new feature, I will just demonstrate how that works by just copying this. So if we were to put this into our old R, so that's the window here, we just get an error which is basically complaining about that it doesn't understand what the slash is on its own, and we won't be able to fix that. But if we run this in the new version, so what this is doing is it's just a function that takes a vector or takes a number and adds one, right? It's pretty straightforward, and that runs exactly as you might sort of expect it to do. So I guess additionally we would have run something more along the lines of function X, and then if I was being good, I would probably make sure I had the scope set properly with brackets and things, and that would come back with the same answer. But the idea, I think, is that this is essentially just less characters to type. certainly for me, cognitively, it looks a bit weirder, and it's going to take a little while to kind of get used to seeing this written in code. I don't even really know what to call it. I guess it's the anonymous function declaration style or something. I don't know if there's an official term for this, but I suspect it will become prevalent in a lot of code. So we should probably at least get our heads around what the style looks like and that kind of thing. So I don't know if anybody knows exactly sort of the genesis of creating this was or anything, but it's definitely a new feature that I guess we should expect to see in code going forwards. So one place that you can kind of apply this, so we just saw it there in sapply as the sort of function definition kind of thing. But yeah, there's also ways you can incorporate this into, or to get around some of the limitations of the new native pipe. So these bits of code here were just demonstrating how with Magritte, just like Martin did, you could use the dot notation to pass things as a second argument. So if you ever use the grep or those kind of family of functions, you'll know that they have a weird syntax where the thing you want to pass in to be modified or to check always comes second for whatever reason. When the function was designed, pattern comes first, and then the thing you're looking in comes second. And you can use the dot notation to pass the argument in here. And it just doesn't work with the new pipe, as we saw with Martin's example. And so one strategy is to, as Martin did with his plot thing, is to make your own function and give it a sensible name, and you rearrange the order of the arguments so that it works with the new pipe. But you could also do this by using our new notation here to create an anonymous function that gets piped straight into. We don't give it a name, we don't save it in our workspace and things. So what this is doing is it's just going to, if we just look at the example up here, grep L it returns a true-false value for whether it finds this pattern in whatever gets passed to it. And so what we're passing to it are these three words, and so it should give a true if it can find AR somewhere in it and a false otherwise. And if we run the old style, so I guess this would work in no, it won't work in old R because there is no native pipe. We should come to the new R, and if you have to give your functions the names that they are actually going to be called with. So this approach works, and we get back logical vector where it finds array but not in vector and matrix. And then we can use, we might expect perhaps to just be able to do the same thing with this new function approach, but it's actually a bit more kind of engineering going on around it, I guess, because of this requirement that you need to have the brackets available within the pipe call kind of thing, which again, Martin spent a lot more detail than I kind of get about why this is necessary and things. But you can't just use the slash notation. If you ever want to define it like this, you have to put some curly brackets around the anonymous function definition, and then you need some empty round brackets to make sure you're calling the function appropriately. So we run that in here. We can see this runs in the same way, but now we never defined this function we're calling. It's not available in our kind of workspace and things. It's only here for the duration of the pipe, and then it's gone again. And so this is kind of I guess another use case. There's the apply family, and I guess things like map from either from the per package or base R would also make use of this, or could make use of this kind of anonymous function definition. I see there's a few things in the chat. Does anybody want to speak up? Do you have questions or comments on this?
I'll say that that notation, the slash parentheses, as Laurent mentions, you can think of it as like a reference to like a a lambda. The slash is a lambda, and a lambda function is an anonymous function, an unnamed function. So that's kind of the pedigree. I'll also say that I find the notation really foreign to parse. And if you think about like reading code, you think you're reading some obscure Perl or something, sure, you can write these things that are that clever, but it's really hard to parse. But I'll just say that some of the alternatives that were considered were way more obscure. So you should be glad that you ended up with the lambda as opposed to the alternatives.
Yeah, I find it at the moment quite, I would almost say offensive to look at, but I think it's only because I'm not used to it. I guess I never had a problem writing the word function, but I guess we save ourselves a few character strokes every time we want to do this. I imagine in 6 months' time, I felt similarly about the literal string things and was not convinced I would ever want to use them, and now I use them all the time. So they came out in the last version of R, and it's taken me a year, and now I think they're pretty cool. So maybe the same will happen with this notation.
Also, the parentheses around the like in the native pipe, where you have to put parentheses around the lambda function and then some extra parentheses at the end. I mean, once you realize that the function has to have parentheses at the end, you realize that you couldn't do without the parentheses around the lambda function, because then it's like you'd be invoking grepl with the return value of grepl. You'd be treating as a function within a function, as opposed to treating the lambda function as a function. But somehow you can understand why it's necessary, but at the same time, it's a very complicated syntax.
Yeah, it feels a little bit like I guess we could also define, if this was a longer function than just grepl, we'd have to have another set of curly brackets inside to define the scope of the new anonymous function. And right. Whereas this is a relatively simple one-liner. But I suppose if it needed to be more complicated, maybe we should declare it and give it a name and use it in a more traditional fashion, shall we say. But yeah, I suspect these are going to become de rigueur, and we're going to see them in a lot of code. So it's at least good to be aware that this syntax exists.
You mentioned literal strings, and I know that's not a feature of this R, but could you just say, I don't think it's widely appreciated about.
Okay, yeah. So I wish I had an even older version of R that I could show this in. But yeah, so the literal strings are a way of how to start this. So there are certain characters which are quite complicated to represent in R. I guess I'm specifically thinking of like the backslash, but there are certain others as well, right? Where if you, this is going to fail to have. So for instance, I've tried to make a slash as a string here, but it's somehow gone into a loop where I'm now into a new line, and this is what's eventually come out after a few returns and then a closing bracket and things. And this might not seem straightforward to understand what's happened here. And that's because in this example, the slash here escapes the double quote. So we started our string with a double quote, and then by putting a slash and then another quote, it's saying, I want this string to have quotes in it, not to end it and say finish here. Which may be not what I intended, right? Maybe I wanted to just have a slash in there. And so maybe you actually need to represent one backslash in R, you need two backslashes to be written down. And the same is true, for instance, if I wanted to use the single quotes and I wanted to put one in there. And there are other characters where this is true as well. And so it can be you can end up with incredibly verbose strings to represent actually really small things if you need to, for instance, write a URL parser that has multiple slashes in and that kind of thing. And this is particularly the case if you're trying to do regular expression pattern matching, so using functions like the grep-l over here. You can end up to match, I think, 2 slashes you need to draw, and you need to write out 8 in your regular expression because you're escaping things at multiple levels, and it's quite complicated. So now I'm trying to remember what the syntax is to do a string literal. It's also a bit strange. I think this is correct. I could just remember what layout my keyboard is. And so this looks worse than what I had before, but the important parts of the declaration, right? And so instead of making just a single string with the double quotes, we're using this lowercase r, double quotes, and then a curly bracket, and then everything inside that, all the way up to the closing curly bracket, double quote, is taken exactly as I write it. So if I write a single slash, I mean a single slash, and I'm not escaping any other characters. I'm not trying to do anything strange with it. The same is true even if I put in, for instance, another curly bracket. That is also included in the output. So this is a way of defining, of more easily writing exactly the string you want without worrying about how R is going to interpret it, and how the sort of combinations of characters you put together might well sort of impact one another, where, for instance, in this case, the slash escapes whatever comes after it. And so, yeah, it's a slightly strange and verbose way of doing it, and it feels like you actually end up writing more characters than you would by just kind of carefully escaping things. But actually, sometimes it's really nice to just be able to say, I'm going to write exactly what I want in between these two slightly more verbose delimiters. And if you were wondering about, so you can put spaces in things, and they will also get included. And if you were wondering about how you could include a curly bracket with a quote after it, so because we could also put a quote, for instance, in the middle here, and that just gets included as well. If you wanted to include this, then you can also escape things by using round brackets, and that also works. So these two things are the same, right? So it's quite flexible, quite verbose, and a little bit strange, and I don't see them that often. As I say, it only came out a year ago, so in R 4.0. And I think it's taken a while for people to get used to it. But sometimes when I'm writing regular expressions, this is a really, really cool thing. But definitely an intro from last time, not this time. Does that work, Martin?
Yeah, that's great. I guess it's R double quote and then like double quote whatever character. So it could be like exclamation mark if somehow, or
is it not just brackets? Okay.
Yeah, it's just like anything is the opening and the closing. All right, so I lied.
There is I think there's a thing with like you can put something like this. I can't remember when you need to use that. Yeah, it's a strange declaration that's a little bit different from base R, it is base R. It's all there, but it's just a bit different from what we've been using for 20 years or so.
If you want to get help on this function, is it just $R, or what's the actual function called?
That's a very good question. What happens if I do $R? So I suspect it's probably this. I have no idea.
Or what's the name of this? So like I can look, because I have a feeling I won't remember all of this. How do you find help on it?
So the concept is called, oh, wow, I've never seen that error message. The concept is called string literals. And I guess I would Google string literals in R and hope that I got back, guess the help page from the R homepage or something. this seems like
that
this seems
kind
like a
of
good
goes
example.
for all of these new like additions like the anonymous functions and like the new pipe. You know, how do we access help on these more, I hate to say, kind of esoteric characters, new characters in our whatever, or new functions in our, what's the best way to get help on these if somebody hasn't found these before and doesn't know what they're doing? You know, it's not as easy as a question mark, is it?
Yeah, so normally for the, I'll see what happens with the pipe. So I guess normally my go-to for these kind of strange symbol ones, I always need to look up what one ampersand versus two ampersands does. Like which one should I be using in a particular situation? And I know you can do, so for the ampersand example, if you put it in backticks, that should work. So that gets you to the help page for this. So I don't know if the same works for the new pipe. No. And I'm not convinced this will be beneficial either. So
Can you use the function help?
I'll wait for it to finish searching. I guess I can do it in the second window. I never use the function help. Presume it's just, okay.
Yeah, I don't know how widely it's supported.
Oh, there we go. Okay, so help with the, so I typed in help with the pipe in quotes. And that seems to have got me straight to the pipe operator help page. So I don't know if the same is true. I guess it wouldn't, this version of R doesn't have the pipe operator because this window is the older version of R, so it wouldn't find it no matter what I searched for. And I don't know about with the string literal stuff. I have a feeling that's not going to work. I don't know is my answer. Adine, I'm sorry I can't answer that question.
No, thank you.
It's a good point though that actually I have no idea how I would go about finding the help for that, other than Googling and hoping that something more verbose than R's own inbuilt kind of search thing gets me there.
Yeah, I'm more thinking of like if somebody is given a script and doesn't know what something does and doesn't know what it's called, you know,
Yeah.
Googling a lowercase r with a quotation mark and a bracket or whatever isn't the kind of thing that normally returns a useful Google search.
Yeah, no, that's I mean, you're absolutely right. Trying to Google what I'm doing here, probably unless you find like the slides that I gave at a talk about this or something, right? It's probably going to be a bit of a tricky one. Yeah, I don't have a good answer to that. Maybe we just need to be careful with our comments to say, I am using string literals here, and hope that that's good enough. Yeah, those are the two new syntax things, right? So we've got these new function declaration things and the new pipes, and those I think are going to be the most significant kind of user-facing changes as users of R. But there's a few other things that I kind of went through there. So there's a massive long list on the R news site of things that have changed in the release and things. Some of them are very small, some of them are significant user-facing changes. But there's a few things that I kind of picked out that I thought were interesting that I can just run relatively quickly as examples here. And we'll run them in the old version of R, so put a bit of a space in. And just see how they work slightly differently. So one of them is concatenating two factors, which used to behave in a really strange way that I really didn't appreciate. So the code here just makes two factors of each of length 500, one with lowercase letters, one with uppercase letters. And then I'm just going to use head because it'll print out something really long otherwise and fill the screen. But we're just going to use the C, right, the concatenate option, which I have my own idea of what I think this could do. But this is how it used to work in the old R, which is that it would turn it into an integer vector, and this would be a 1000 number vector, or a length 1000 full of integers, which is really not what I expect at all when my inputs are letters that have been used as factors kind of thing. So I don't know why this was the behavior, but it's certainly not what I as a user would expect it to do. And now in new R, it does probably what I would expect, right? So now it still comes back as a factor. It's got the number of levels, in this case, are the lowercase letters and then the uppercase letters, and it's retained things to still be, or match those levels with the values built into it. So we still get back. Essentially, it's just like if you concatenated two character vectors together. And to me, this feels way more intuitive than how it used to work. So, but clearly a sort of significant change if you've written code that kind of worked in the old way, and now you're getting back a factor, and perhaps that's doing something quite different. So yeah, that's a sort of relatively small change, but might have impact on people's code. There's also some performance improvements for factors and things, which can be quite dramatic, and maybe if you've shied away from using them, maybe they're more useful now. So this, again, we're going to make a really big factor of lowercase letters. This time it's 10 million values rather than just a few hundred. And we're just going to look at how long it takes to search that. So we're going to use this grepl function again. How long did it take to search for the letters K through to P in our factor? So if we run that in the old R, it takes a little while even to generate the factor of length 10 million. But we can see then the operation to do this searching takes like 2.5 seconds with the old version, and it takes less than half a second with the new version. So there's quite a significant performance increase. And actually, they've done these same performance tweaks, which are basically you're searching the way factors is the set of levels, and then the indices that represent that correspond to those levels. And before, the code was converting everything to a character, doing these text operations, and then converting them back. And now it's working on the levels. So there's much smaller amounts of data to work through in most scenarios, which is where these performance benefits come from. And so we see them on all of these kind of text searching and text operations. So it also happens to work pretty well for the gsub command as well, which again, if I run, I think the performance is actually even better in this instance. You can clearly see the difference, right? So this time it took more than 5.5 seconds, and it's still half a second for the new one. So again, if this has been something that's really slow, kind of these kind of operations on factors for you, and you've ended up converting when you don't want to, because factors may be what you wanted to stick with, these two operations now work much more. And everything you find under the rep homepage, which all have horrible names, they all work in a more performant fashion than they used to. This is an additional thing on that homepage, which I'm going to skip over in the interest of time, mostly because I never know how to pronounce any of the functions that you find on that page. And a couple of other little performance improvement things as well that are quite significant. A few versions of R ago, there was this concept of alt-rep, alternative representation, the way the data is actually stored at the kind of C level inside R. We've had a really great developer session on that from Gabe Becker and Luke Tierney about how that works and things. But they've made a few performance improvements to certain specific types of vectors that kind of benefit from that, particularly if you're doing operations like duplicated, which finds you which elements appear, or which are the duplications inside a long vector and things. And so if it's already sorted, that should be quite quick because you only need to check the neighbors and that sort of thing. But there weren't good algorithmic approaches applied in the background, and they've made some changes here. So this, if we just run this code, it's just going to it's going to sample some numbers, and there's definitely going to be some duplicates in there. We're going to sort it, and then we're going to make a copy that loses its own internal knowledge that it has been sorted. So this kind of knowledge of that it is sorted is something that's one of the benefits of this alt-rep approach. And by doing this slightly bizarre operation here, we actually get rid of that knowledge. So in this case, Y knows it's been sorted and Z doesn't know it's been sorted. And then we run the duplicated operation on them. And in our new version of R, it was essentially instantaneous to come back with the answer about what has been duplicated and what hasn't, whereas it took about a second with the kind of the version where we've removed that information. And we can actually see in our old version of R, and I don't know quite why there's this discrepancy here. So for Z, the values are almost exactly the same, and for Y, it's actually twice as slow. So there's clearly been some changes into how this is working and things, but certain operations with these kind of vectors now work really quickly. And this is the sort of thing that I've certainly done in the past, right, where I want to sort things and then I want to find things that are replicates right next to each other kind of thing. And this is it's essentially instantaneous now to do this. And then, yeah, there's a few other really small things that I'm not going to talk about too much here. But a few extra points that kind of are noted in there that I thought at least worth discussing or sharing or being aware of. One is there's this change to the kind of standard version of C++, which is going to be used for building packages. And I know we've had discussions in these about particular types of C or C++ code and whether it's been appropriate to use certain versions and things. And with this version of R, there's kind of an over-the-board increase from C++ 11 to 14. So if you make use of that kind of code and things, it's probably worth being aware that actually there's been a ratcheting up of what is assumed to be available on build machines and that kind of thing. So that's probably quite useful to some developers. There's also a note that this is the last version of R that will be on 32-bit Windows, which is probably most significant for the people that maintain the build machine at Bioconductor. And we don't need to worry about it as developers for at least another 6 months because we'll be using R 4.1 until at least the next Bioconductor development cycle. But if it doesn't need to be supported on 32-bit Windows, we don't need to build packages. Packages that distribute binary things don't need to have 2 copies for 2 different versions of Windows and that sort of thing. So it's probably a little bit further down the line, but we should be aware that that's going to happen. And also one other significant thing is that somebody has taken the time to translate a lot of the things into Lithuanian, which I don't know how many languages is currently available in, and error messages have been translated to and that kind of thing. But somebody who is thanked in the notes and things has taken the effort to put it into Lithuanian. And if this is something that is interesting to you, like you know that a language that it isn't represented in and things, there's actually you can click this link, it will take you to the Use R conference, which is happening in 6 weeks or so. But there's a whole workshop on how you can help R and the R core team and things translate various bits into different languages, and also how you can apply that to your packages and things. So if that's something that's interesting or sounds useful or you want to contribute, there's some help on that as well. And this session, which I think if you've registered for the conference is free to attend, might be a gateway to you contributing. So that's the few changes I wanted to summarize. Thanks for listening. Does anybody have any questions or other things they want to contribute?
I was amused by this comment in an issue which highlights that apply now has a simplify argument. And I was also tracking a problem that Dario had on BioC Devel, and it has to do with the .R profile and writing to the base environment. I don't think that was exactly right on what Dario's problem was, but because the base environment is locked, .R profile can't create variables. You need to create a local environment before creating variables. And the final thing I wanted to say was, I like this translation idea. I'm basically only an English speaker, but I'd love to make like a core package like BioC Manager, translate the messages that it produces into different languages. And I'd be interested in talking with anyone who wanted to do that translation for one of our packages.
So the session is actually being led, I think it's Michael Lawrence, and I think it's another Michael, who is, they're giving the session at UseR. Unfortunately for me, it's at 1 o'clock in the morning German time, I think, so I probably won't be attending. But it sounds like a really cool thing. Like, I've never thought about translating anything in my packages themselves, but I guess I'm aware that some of the error messages we get are in different languages because sometimes we see them copied and pasted into the forum and that kind of thing. But again, as a native English speaker, I've got no idea how widespread support for that is, whether it's only a few base functions or, yeah, it would be really interesting to look into it and get feedback from users.
Sorry, Mike. As a kind of segue into that, I've been trying to find out how many people within the developer community speak how many different languages. So on the Slack channel for the CAB, the public Slack channel for the CAB, we've been asking who does what languages, and within the community advisory board, we've got 9 languages that different people speak and speak sufficiently well that they'd be able to translate things. And then a couple of other people have been chiming in that they speak other languages as well. So I think we're up to like 11 languages, but it is something that I've been trying to identify people that would be willing to actually consider that. So maybe it's something we could bring up at the conference, the annual conference, Martin.
In which case, if there's no more comments, thanks very much, everybody, for attending. Thank you, Martin, for leading us through the native pipes. That was really, really interesting. And yeah, next week next month, we will be back to the 3rd Thursday. So this was a 1-month blip to be on the 4th. So I think that's the 17th of June. And hopefully I will see you all again next month.